Hello, my name is Brandis, the PI for ESM, and I'm here to give my poster entitled Impact of NASA's Entry Systems Modeling Project on Planetary Mission Design. Every mission that enters an atmosphere relies on specialized expertise and tools for designing the entry system. ESM is the only agency project invested in EDL model and tool development and look to deliver significant changes to the state-of-the-art in a time frame that can benefit and be infused into missions. ESM groups its research efforts into four main investment areas chosen by talking to stakeholders in order to solve problems that are not just technically challenging and interesting, but relevant to flight projects and NASA goals as well. Firstly, we have predictive materials modeling, which provides detailed material response modeling of TPS at the micro through macro scale and at the fundamental and engineering levels. Aerosciences is a catch-all area that covers research into many elements, including parachutes, aerodynamics, and material roughness augmented heating. GNC is currently focused to look at updating the agency's main trajectory code post-2 and to look at multi-physics coupling. Finally, we have shock layer kinetics and radiation, where we look at shock layer radiative heating of spacecraft, quantum chemistry, and benchmark experiments, typically performed in the electric arc shock tube, EAST. This poster overviews some current examples of ESM's impact to NASA missions and a couple of relatively new opportunities. ESM has a partnership with the Earth Entry Vehicle mission to provide technical oversight of research specific to their mission requirements. This work covers high-fidelity TPS response modeling with a focus to understanding failure modes of woven TPS materials. As EEV is using a chute-less aeroshell, it is important to understand the capsule aerodynamic behavior during entry. ESM is providing insights into EEV dynamics by performing simulations with the free flight dynamic CFD technology implemented into the US 3D code. Next up is the other main half of the Mars Sample Return mission, the Sample Return Lander. For SRL, we have demonstrated simulations of MSL showing a fully tiled heat shield and differential recession between the tiles and RTV gap filler, and also looking at the effect dust particles have on aeroheating. A new start activity for ESM started last October, the Medley 2 Deep Dive, which aims to provide a continuation of the analysis of the recently obtained flight data and provide insights into future mission design, as well as further development of a material response model for NuSil-coded Pika. Next up is the Dragonfly mission. Radiation is a significant source of heating for Dragonfly, and ESM provided benchmark shock tube radiation data for Titan entry, along with validated models to be used for the design of the thermal protection system. ESM's free flight CFD technology is again being used to understand and model the aerodynamic stability during the long Dragonfly descent. ESM is also developing a fully 3D material response modeling capability within the Icarus code to allow simulation of more complicated flight-like geometries. Lastly, we have Venus, with two recently announced missions, Veritas and Da Vinci, so ESM would be interested in talking with those teams in the future and discuss if there are mutual beneficial collaborations, and could include things like providing benchmark radiative heating data for Venus conditions, GNC and improvements for aero capture, augmentation to convective heat flux due to roughness, and improvements to modeling and understanding woven TPS materials. If you have any questions, feel free to reach out to myself or any other member of the ESM leadership team, and thanks for listening.